This is young Lena. She was working as a software engineer at a company. And as you can see, she is still, as we say in German, a bit green behind her ears. Like she's trying to write on the screen with a pen. Dumbass. But she was starting out using Linux on her computer. And of course, she went for Arch Linux because she likes a good challenge. And she had a lot of fun with it. But also in her everyday life, young Lena was working a lot with containers. And with containers, we learn a lot of new paradigms, like that we should write everything declaratively, right? When we have a container, we write the Dockerfile. It has all the instructions in it, and we can always recreate the system from that very Dockerfile. So it's like the declarative declaration of what we are trying to run. And young Lena was like, but why isn't my laptop working like that? I'm always installing stuff, uninstalling stuff again, always running pacman commands to install new packages and so on. And it wasn't really declarative, right? You run commands. When you throw your laptop down the toilet and you get a new one, then you're going to have to remember all of these commands again. So what she started to do is to write a small tool called pacmanfile, where you can write a declarative list of all of the different things that you would like to have installed on your computer, on your Arch Linux computer. And it would take this list and make sure all of those things are installed, and everything that's not in this list gets uninstalled. There was some mild interest. I think there are like a bit more than 40 stars on GitHub for this at the moment. But still, it wasn't very satisfactory, right? Because it was only about the packages that were to be installed. Everything else about the configuration of her system, like what are the system services that I want to have running? What do I want my color scheme to be? And so on. All of this she needed to configure by hand still. So at some day she found a tool called GNU Stow, which led her to create a repo with all of the configurations of the different packages that she used every day. And you can run GNU Stow to then get all of these configurations out of a Git repo and get them onto your system in your config directory. And with GNU Stow, she was quite happy. She had all of the configurations in here, but this was only affecting her home directory still. So to set up the configuration of the computer itself, what she did is she wrote a blog post, and the blog post was basically mainly for herself, right? It was her own kind of documentation of how to set up her own operating system and how to deal with that. The blog post is quite extensive. As you can see, it covers all of the different parts of setting up Arch Linux in exactly the way that she wanted to. So still, she wasn't really where she was with containers. She wasn't really using something like a Dockerfile. And it was all pretty annoying. So at some point, she discovered Nix. And Nix is a way of how you can set up any computer, or any Linux computer, let's put it like that, in a declarative way. It's a way of how you can write one declaration file, and it will know exactly how to bootstrap and how to set up your computer. And this computer can be a laptop, like this one, or it can be any server that you are working with, any VM that you have on the cloud somewhere, or anything like that. So she saw the light. And she switched to using NixOS in her everyday life. Now, young Lena is not the only one who went through that journey. Here's an example of a YouTube channel that talks about Linux stuff quite a lot, and you can see exactly the same history, right? They started out creating Arch Linux content, then they did a bunch of stuff they learned, and now they're doing NixOS stuff. So this is not unique to young Lena. There are also other people who start out green behind their ears and then want to define everything declaratively, and they land on NixOS. So who am I? Why am I telling you this story, you might ask? I am old Lena. Hi, nice to meet you. And I work at a small company called Bespinian. We do cloud native work with our customers, so we help them migrate their applications and their computers onto the cloud, sometimes using NixOS, not as much as I would like to, but sometimes. Now, let's talk a bit about what Nix exactly is, because it can be a bit confusing if you have already heard about it or worked with it. On the one hand side, Nix is a package manager. Nix was created in 2003 by a person called Ilko Delstra as his PhD thesis, because he wanted to create a declarative system. So Nix as a package manager, you can install on any Linux distribution, and you can also install it on macOS, for example. And you can use it to manage the different packages that you have installed on your system. And Nix has three main goals. It wants to be reproducible, so whenever you run or you build a system or you build a package or you install something, it should always come out in the same way on the other side. It should be declarative, we already talked about this, and it should be reliable. So that means, for example, that one of the dependencies of your packages gets updated. That shouldn't break your whole stuff because maybe it's not compatible anymore or something like that. You have that with many other package managers where this package depends on version 3.4 of a dependency, this package depends on version 4.6, and then your computer just installs 4.6 and this old package breaks, right? And that's why Nix does a lot of stuff to isolate these dependencies. And we have gotten used to this sort of doing things by all sorts of package managers like NPM or like the Go package dependency system and so on. They really isolate their dependencies and they have log files for every dependency that you use. On the other hand, Nix is also a language. So there is the language that you used to define your packages, that you use to define your operating system, and so on. And this language is a functional language. I will show you an example afterwards. And it's also a pure language, or at least how it's being used in my case, it is pure. And that leads to everything that you apply to be idempotent. So when you have the same configuration and you run it, it will always output the same result. Also, we already heard it a bunch of times, Nix as a declarative language. So that means that you don't just make a bash script that says what to install on your computer, and it has a bunch of install commands that are in there. You could say that's also kind of me defining in one file what I want to have installed, right? But when it's declarative, then I'm not defining the different steps of how to get to my result. I'm just defining the result that I want to have, so the configuration that I want my system to be in. And then Nix will figure out the way of how to get there. Also, Nix is a language that is made specifically for operating system and application configuration. Because you could say, yeah, we could also just use YAML or JSON or any other thing that we know and love to define our system. But NixOS has a bunch of helper functions, or sorry, Nix, the language, has a bunch of helper functions that help us to get there more easily. And thirdly, also an operating system. So as I said, you can use Nix, the package manager, on any kind of system, like any Linux or macOS-based system. And you can use Nix, the language, to declare all your packages and so on. But there is also an operating system where you can define everything with Nix down to the very lowest part of the operating system. And this operating system is called NixOS. That we will look at today as well. And NixOS has both stable and rolling releases. So it's kind of convenient if you want to switch between the model that maybe Ubuntu follows with stable releases, where it releases every half a year. Or you can have rolling releases like Arch Linux. You can have the best out of both worlds, and you can switch between the two worlds. It's also an atomic system with rollbacks. So whenever I mess something up in my operating system, firstly, it tells me there is now a mistake in your configuration, and it will not apply the whole configuration. So we'll either apply fully or not at all, and not apply it halfway through and then fail. but it will do it fully or not at all. That's what the atomic part means. And rollbacks means even if I still manage to mess something up, I can go back in time, go back to my old configuration, boot from that, and it will still work. That's very convenient if you're experimenting a lot like I'm doing. Plus, it's sort of unbreakable. I think some people still manage to. That's why the winky smile is there. But it's pretty hard to break because you have this validation that if you would write an invalid configuration and you would try to apply this, it will do some validation on that and it will not even let you apply the configuration. And even if you do, you still get the rollback feature right. Nix also has a very vast ecosystem. So how it's developed is mostly on GitHub. And this is one of the most active and the largest, and one of the largest Git repos on the whole of GitHub. You can see the last commits was 3 minutes ago. There have been 900,000 commits. So this is, I think it's the most active repository on GitHub, and probably even in the world. And this repository contains all of the different packages that I can install on NixOS and that I can make my system consist of. So it has around 120,000 packages all in all, which is more than Arch Linux and the AUR combined. It's more than any other Linux distribution. It's more than Homebrew on macOS. So really, if you have a package that you would like to use, chances are pretty high that you will find it in this very active GitHub repo. Also, I don't know if any of you know this project called Rapology. It shows you a comparison of these different package repositories. And here we can sort it by most up to date. Up to date, I think. And you will see that it's also at the top here. So it's not just that it has a huge bunch of packages, but it's also that they are by percentage the most up to date in basically the whole Linux and Unix ecosystem. And also the community is very active, so there are a lot of conferences and meetups all around the world. As a coincidence, tomorrow there will be NixCon in Rapperswil-Jona. It's taking place in Switzerland this year, so I'm very much looking forward to go there. And to do a bit of shilling, we also organize some Nix meetups. There is one in Zurich here, then there's another one in Bern that a friend and I are organizing, which is taking place on the 21st of October, if you don't have anything to do yet on that day. So you can see it's a huge ecosystem, it's a very active ecosystem, and it's also a very active community. So there you don't need to be worried about just trying some weird edge thing. But what does it actually look like? Here you can see an example of the Nix language and how I can define my operating system and what I want it to look like. It might look a bit weird if you're not used to it, but if you think about it just being a functional programming language, then it's a bit easier to understand. Like with any good function, you have some parameters that you can input into the function, and those are what we have on the top. So we have one parameter called config and another one called packages. Config is all of my configuration, so I can cross-reference stuff from my configuration. And pkgs is my packages repository, so that's the GitHub repo that I showed you before, where you have access to all of those 120,000 packages. So these are the parameters that I'm giving into my function that I'm actually executing. And then what I'm writing down there in the other two brackets, this is the output of my function, so kind of the return value. And this will be the configuration to my operating system. And you can see I put a bunch of examples here. I can import from other files. I can set parameters, like I can set my username to Lena, so it's going to create a home directory with my username called Lena, and it's going to create a user with my username. It's going to give it specific permissions and so on. And I can install packages. Like here I'm installing from this pkgs, from the packages repository that I just showed you, I can install LibreOffice or FZF, the fuzzy finder. And as you can see, I do all of that in my configuration. Now all I need to do is run the switch command, which will switch my current operating system to the latest version of the configuration that I'm building. And then I can just reboot into my new operating system that exactly fulfills this configuration that I wrote here. And I would quickly like to show you that in action. I hope that's big enough to read. So this is my repository where I have my whole operating system defined. As you can see, it's just a Git repo, so you can find all of that on GitHub as well. And here you can see some examples of parameters that I have defined for my system. And down here, what's very convenient is NixOS also has what they call modules. So, for example, if we want to run a specific program on my NixOS setup and I want to run it as a systemd service, then all I have to do is add it here to this services object. So you see I'm now running fw upd, or I'm running a printing service, and so on. And if I were to run if I wanted to run another application, like, for example, some of you might have heard of N8N, which is an AI automation platform, then all I need to do is add n8n.enable equals true. And now if I apply this configuration, that is going to add an N8N systemd service, and it's going to start it up so that I have access to it. So let's try that. I have a little helper called make system, but all it's calling underneath is just the NixOS command line, right? And now it tries to figure out what is the difference to my previous configuration, to my previous operating system, and it's going to try to apply that. And it tells me, just like, for example, Terraform does, or any other declarative tool for infrastructure, it tells me what is going to be the difference. So it tells me it changes a bunch of libraries, and it's going to add a bunch of libraries or packages like N8N and a bunch of the dependencies that it has. Since I'm changing something on operating system level, I need to put in my password, and now it's creating the new configuration and switching over to it. And now when I visit my browser, you can see I now have N8N running. And on any other system, that would have been a lot of looking into the documentation. How do I start N8N? What are the different dependencies that it has? What are the different maybe database services that I need to start in order for it to run? And so on. And the NixOS is literally adding one line to my configuration, and I have it up and running. Now also, there is obviously documentation for that, because I can set different parameters and so on. And they have a handy search page for options that you can set, like this N8N. And here, if I search for N8N, then I can see the different parameters that I could set for having N8N started. And you saw before what we did was set the enable to true, and now we have N8N running. And all of this is now functional. So for those of you who know N8N, it's like a workflow automation software, kind of like Zapier, or kind of like if this then that, if you know those. But it's very much focused on AI, because I'm sure you all wanted to hear the word AI during tonight's talks. It's not present enough yet. So what I can do is, here in this example, I just set up a simple chat input, and then I have Olama running on my laptop so I can connect to it and so on. I'm giving it a system prompt, telling it to be very mean to me and so on. And now I can chat with it, and it's running all. Okay, I guess. Okay, I know why that is. I chose the wrong. I chose the wrong model in Olama. There we go. Yeah, and now you can see it's all running, and it's all just running because I added one single line to my configuration. And now I just showed you how to configure my whole operating system. You saw that I needed root access for that. That's because it's changing stuff on the system level, but I can also use Nix to configure my whole home directory. So I can use it to configure stuff like my NeoVim configuration. I can use it to configure stuff like the color scheme of my desktop. I can use it to install packages as my user, like you used to do with Homebrew, maybe on macOS or anything like that. I can also show you an example of that. So here you can see this is my the configuration of my user, and here you can see all of the different packages that I have installed. So I just add them declaratively to this list, and then I tell it to switch to the new configuration, and it's going to install all of that. Now, how does this actually work in the background, and how does NixOS or Nix actually achieve all of this isolation? So it does it a bit differently than other more traditional systems. There is something in NixOS called the Nix store. And you can see it's a directory at my root level. And this little lock means that it's read-only. So I, as a user, I cannot change anything in there. I can also only change stuff via the Nix CLI. And by that, it can ensure that everything that gets done in this package is under its control. And if I do an ls here, then you can see all of the different packages that were installed onto my system through Nix. So instead of kind of crowding my whole operating system, my whole .config folder, and so on, with packages that I install, especially when I'm trying to experiment, I'm always installing stuff, uninstalling it again, and so on. Instead of polluting my whole computer with it, it puts everything into this Nix store and then creates symlinks wherever necessary. And you can see that all of these packages that get installed via Nix, they have their version, but they also have a hash. And that means that in all of these packages, there are all of the dependencies are referenced of that package exactly with their hash. Like we're used to from any good package manager that has a log file or anything like that, all it references is always directly the hash. And that means that on my system, I can have 5 different versions of GCC installed, for example. If I have 5 different packages that depend on 5 different versions of GCC, I can have all of those installed, and they individually will reference the Nix store via those hashes. And even if their dependencies change, it will again change the hash, and so on. So I get complete reproducibility, and I can also have full idempotency by always referencing those hashes. The only downside that has is that over time, obviously, this Nix store will grow quite a bit, right? Because I might have many different versions of many different packages that I maybe don't even use anymore. And this will use a bit of disk space. So that's one of the downsides of NixOS, that it uses quite a lot of disk space. But they have a cleanup command where you can say, I want to clean everything up that I haven't touched in the last 14 days, for example, here in the last 2 weeks, and then it will periodically, and you can also automate that via the configuration that we saw before, so you can automate the whole maintenance of this Nix store. So that's the whole idea behind Nix and NixOS, that you have one file to rule them all. You have one configuration file. It defines exactly what your whole operating system looks like, what your home directory looks like, and so on. Let's, to summarize, let's look at a bit of at some of the advantages that are behind Nix and NixOS. As you can see, it's a declarative operating system as code, and nowadays, as the pupil folks showed before, you want to have everything as code, also infrastructure. So you can even have your own computer and your own operating system as code. You can customize everything. So everything that you could usually customize via config files or stuff like that, you can also customize via Nix. You have proper rollbacks in your configuration and in your operating system. So if you messed stuff up, you can always go back. You usually have no dependency conflict issues, like what I mentioned before. If you need different versions of packages, you won't have dependency conflicts. You can also have separate developer environments. So if you and your colleagues are developing a software together, then you can have your own configuration file for that environment that you develop in, and you can share it among your colleagues. And as I said, it has a very active community. Obviously, there are also some downsides to Nix and NixOS. It has a very steep learning curve, and it's quite different to any other Linux system that we are used to managing. The documentation is sometimes not that good, which is surprising since the community is so active, but I guess just nobody has time to write documentation. Some of the features are still experimental, and they have been for quite... Whoa. Somebody doesn't like that. Have been experimental for quite a bit, which is a bit annoying if you need to enable experimental features just to use the operating system. It sometimes doesn't have the best error messages that help us with. Also, it's not always FHS compliant, which means, as you saw with the Nix store, it has a different layout of the file system of the Linux system than compared to other Linux distributions. And what I mentioned before, it has some increased disk space usage. So it's kind of a balance, like everything that we have in IT. It's not a silver bullet, but I think it has a lot of upsides. And I think young Lena would agree with me. One last thing to tell you, I really encourage you to try out NixOS and to play with it. One thing, if you install it, the installer looks a little bit like this if you do it graphically. It's going to get stuck for a long time at 46%. Don't worry. It's just doing a lot of things. It's thinking very hard, but it's going to continue. So just as a little heads up for that. But still, I do encourage you to try it. Here are some resources. You will see about those when you get the slides. So you can use all of those to start out with Nix and NixOS. And with that, I thank you a lot for your attention.
So I started the first questions. You have some fancy resolution that we couldn't catch there.
No.
So question would be, how do you change the resolution?
So that would be in, oopsie. If I go into my configuration again, then I have a configuration file called windowmanager.nix. And here you can see the whole configuration of my window manager, which is Hyperland. And here I have the monitor configurations, but I haven't changed it for HDMI, so I guess it's just the defaults that are weird. Maybe but here I would change it.
Maybe it's just too high for our interception device.
Maybe.
I don't know. Any other questions?
Yeah, I wonder if NixOS can solve a problem when you install a system that you want to encrypt the hard drive, and sometimes you want to do it later if you want to install it very fast. Can you do this also with NixOS? Is this on another layer basically? Or can I add in the configuration, okay, I want to encrypt this disk with this encryption method, and here's the password that you use for this?
Mm-hmm. So there is, like I said, the ecosystem is quite big, and there is a tool called Disco, which is this one here. And because NixOS usually it relies on you having a pre-partitioned hard drive and so on. And with this one, you can also do that in a declarative way. And then it provides you, so if you have a configuration like I do, for example, I have a disks.nix, And here you can see this is the partitioning of my disks and my file systems and so on. And here I'm using lux to encrypt this drive. And then with Disco, I can run, when I have a new computer, I can run one command. It's going to partition all of the disks in exactly this layout with Disco. And then it's going to install NixOS with my exact configuration and my home configuration with all of that.
Cool. Any other questions?
Thank you. Very interesting presentation. Very interesting project. A few questions maybe. So here you focus on the Linux. I wonder if there are any plans to also try with Mac or Windows. So for sure Linux is free and is maybe more transparent. I don't know. So this is one question. Second thing also. So here you test on the laptop, but wondering like mobile device and so on. So this is also interesting, like cross-platform. And third thing maybe, so a very big project, a lot of commits. I never saw such a big repo. And how do you want to monetize this, if you plan? And what's the roadmap for future features? Thank you.
Okay, thanks. That's a lot of questions. So the first one, to try it on different operating systems. So the easiest way to go, obviously, is to just use NixOS. Then you have everything installed, and it's ready for you. If you use any other Linux distribution, you can just install Nix, the package manager, on top of it. And because it does everything independently in the Nix store directory that we saw before, you can even use it non-destructively on top of any other package manager. If you want to use it on macOS, you can do exactly the same. So on top of macOS, you just install Nix, the package manager, and it will also work completely independently and non-destructively by putting everything in the Nix store and then just symlinking stuff. There is also a project called nix-darwin, which you can use to configure your macOS, the operating system, in the Nix language. So then you can set, like, I want to have the dark theme of macOS. I want my user to be called this and that. Exactly what I could do in NixOS, you can do all of that on macOS too with this nix-darwin project. And if you want to run Nix on Windows, then you have to use WSL. The second question, I think, was about mobile phones, right? There is a project for that as well. I think, I forgot the name. I think it's called Nix Mobile or something like that. But I don't know which hardware it runs on, probably some Librem phone or something like that. But there is a possibility of running Nix on your mobile phone, if you fancy that. I haven't tried it. I'm happy with GrapheneOS, but I think it's possible, yeah. And the third question you'll have to repeat for me, sorry. Oh, the monetization. Yeah, thank you. So just to say, I'm not part of the Nix team or anything like that. I'm just an enthusiast. I think there is no idea behind monetizing Nix, the project. It's a completely open source project, but there are companies, obviously, that make money based on Nix. And it's also being used in the military field sometimes. Unfortunately, that happens too, but because it's completely open source, people can use Nix to monetize it. There is companies that offer CI/CD systems based on Nix, which is very, very useful because it has this strong degree of isolation and reproducibility and so on. Then there is companies that do consulting based on Nix and that use it for their own servers. But I think there is no plan of monetizing the project itself. It's community driven and it's completely open source and will, I think, forever be. Thanks.
Other questions?
You said that on NixOS you can use basically the same package with different versions. So for example, if I have a GCC compiler, I have it in different versions. And the question is it very easy to manage aliases? Let's say I have a project that uses another version of the same package and then another version of the same package, but because it's a script, you cannot easily change everything. So is this a NixOS command where I can switch easily between these package versions for CLI commands?
So when it's different versions of dependencies for the packages that you are using, this is all abstracted away from you. So you don't have direct access, like for example, it doesn't symlink the dependencies of your tools into your path on your NixOS. Like if one of my projects uses GCC as a dependency, that doesn't mean that I install it. That doesn't mean that I will have like the GCC command available in my command line, because it will directly use the one that's in the Nix store using the hash. So this is, you don't really have access to, even if you have 5 different versions of GCC installed, they're not symlinked into your path. You need to go into the Nix store if you want to execute them directly. Now, if you as a user, you want to have multiple GCC versions that you install, then you need to go into your configuration and make explicit symlinks to those in your configuration. Like I can show you, for example, in my window manager configuration, for example, here you can see, for example, I'm referencing this tool called fuzzle, right, which would normally just be a binary, but here you can see I'm referencing a variable from this fuzzle tool, and if I look at so this will be translated obviously into a configuration file for Hyperland for my window manager, but if I look at that configuration file, sorry. And I'm searching for this line that we saw before. You see that it directly replaces this with a reference into the Nix store, so that I always have exactly this version with exactly this hash that is being used. And that's how you could then create your different symlinks and stuff like that, by using those variables in your configuration.
Yeah, I mean, basically I have an example. What I mean is, like, you have 2 projects, and one project uses PHP 5 and the other uses PHP 7. And you run a script in this project, in one project, and the script expects PHP 5, and the other script in the other project expects PHP 7. And the question is, you need PHP as PHP in the terminal, if you can then switch easily between those, or if you have to change the configuration in this case. Yeah.
So there are different ways of how you can do that. One is so the best option, I would say, is to use a project called devenv, if you've heard of it, or devenv, that uses Nix under the hood. And then you would have a local configuration file within the Git repo of these 2 projects. Let's say here you run PHP 5 and here you run PHP 7. I think that's the best you can do, because then your other colleagues, they can also have devenv installed, and it will be taken care of, and you know that everybody will use exactly the same version with the same hash of everything. So it's like kind of like everybody just working in Docker, having the same environment. But you can also do shenanigans by installing different versions. Like, for example, I told you Nix works like a function, kind of, that has inputs and outputs, right? And the inputs to my whole operating system are what you can see here. And here you see, for example, of this tool Lanzaboot, I'm referencing a specific version, and exactly the same I can do with this nixpkgs Git repository, which is the one that I showed you before, the huge one. And here I could have multiple ones that I install, and then install packages from these different versions of Nix packages. And by then symlinking those, you can have all of the versions that exist of GCC. But if it's specific to a project, I would do it with devenv.
Any other questions? What about the pizza?
Most important question.
Good. I'd say we close. Thank you very much.
Thank you.